memory operator, we're going to want to expose the A-tree state number integer as an output, and then we're going to go ahead and just feed that into the geom instance A-tree state number. So each particle, he gets defined an A-tree, he gets assigned an A-tree state number, and then in the next rule, he looks up and finds out what his A-tree state is, passes it in here. Geom instance is going to tell him to go ahead and do whichever state that we've specified. Okay, but what we want to do is we want to say, okay, when this sphere comes close enough to you, I want you to change states. I want you to go from sitting to standing. And actually, let's just take a look at what we've got here right now. Okay, so they all start off sitting. We're going to go ahead and create a new rule. We're going to call this A-tree, let's call it A-tree control. And we're going to have multiple different methods that we're going to look at, or at least two. We're going to go ahead and create a sub-rule under this to organize that. We're going to call this node proximity. And we're going to turn edit on the fly off to avoid unnecessary updates right now. Come back into node proximity, and we want to base our proximity based on the node of the sphere here. And we're going to have the all particles. We know we want to calculate the distance between them, so we'll go ahead and do that. And what we're going to do is we're going to set up a little complex rule that says, okay, when the distance between the particle and the sphere is less than x, then go ahead and change their A-tree state. The way we're going to do this is going to use an expression. We'll go ahead and just set it to 1 to keep it from calculating. Put in the first scalar A, and we'll create another input scalar B, and an output value of a scalar, which is going to actually, we're just going to name it A-tree so we know what it is. And we're going to go ahead and add a float in here. What we want to do is we want to tell our expression if the A value is less than B, then I want to output a new state value of 1, or I'm sorry, of 0, because we want them to stand. And if the A value is not less than B, then go ahead and continue sitting, so a state of 1. We'll see this exactly how this happens here in a sec. But we've got a distance value, so the distance is being calculated between every particle on the node. So that distance value is going to come into the A. So A is our distance. If the distance between the particle on the node is less than B, we're going to use this float for B. And right now we'll just call it, let's do 80. So if the distance is less than 80, then we're going to go ahead and output a new state value of 0, which is the standing state. And if you're not less than 80, then just go ahead and stay sitting. So we're going to need to update the memory operator, because we need to update this A-tree state number. Let's go ahead and expose that input. We're going to connect this A-tree output into the A-tree state, and that'll set him there. Okay, so this is all set. Let's go ahead and give it a test try and see what we get. You know what, let's go ahead and we will make sure our time configuration real time is off, and what we'll do is we'll just go ahead and hit play. We're also going to go ahead and hide the layer, the source guy, which is our animated source character. Okay, let's go ahead and hit play. What we'll see then is all these guys are sitting until the sphere gets close enough to them, and then they go ahead and they all stand up. Okay, so that's really pretty simple. We're just doing distance calculation, and using an expression, we're updating the state tree number. And that state tree number gets looked up every frame and gets fed into the geom instance. We're just going to go ahead and pick whichever state we've got. It plays whatever range we're supposed to. We're going to go ahead and stir this up a little bit. We're going to add another value to the memory operator. We're going to call this a It's going to be a scalar. It's going to be called mySpeed. And mySpeed is actually just going to help us kind of change their playback speed of their states. We're going to go ahead and grab a random value. And for each particle, it's going to generate its own random value. That'll be between 0.5 and we'll say 2.5 should be fine. And what this is going to do is it's going to kind of set up some characteristics for each particle. So now every particle knows, hey, I have a speed value, and I can use that speed value to play back my animation speed. The way we're going to use that animation speed is here in the next rule. What we do is we say, okay, we've got our memory showing our A-tree state. We also want to output our speed value. And then the geom instance has an input here. We're going to use the, where is it? It's master speed. So master speed can be controlled by the mySpeed value. So each particle, looks at his random value that he's got between 0.5 and 2.5, and he says, okay, well, my particular speed value, my characteristic, my speed, I can play back this master speed at whatever my rate is. And so each particle is going to play that back differently. And actually, for this case, what we're going to do is, no, we'll just go ahead and play it out and see. We'll go ahead and record this, and then we'll unpause once it's done. Okay, so this is done recording, and let's see if we can see it very well, but each particle is going to play back his transitions at a different rate now. Some are going to be slower than others, some will be fast. That's just some extra variation that makes them look unique. And remember that we did that by, when they're born, we generate a random value to control a memory value that just, we're going to name it mySpeed, and we can use that mySpeed to control the geom instance master speed. Geom instance has his own, of course, playback speed here, or there's the master speed. And the master speed is normally it would just be used to drive all particles, but when we expose this input, it's going to allow each particle to control it himself. It's also got this variation here. We've kind of circumvented that by just using a random assignment. Okay, so here's one kind of setup. We're going to go ahead and take this a little bit further. We're going to do this in the next video. So we're going to go ahead and save this out as, we'll call it CharAnim Midway.